More dynoing of intakes. So we got our 521 here, Super Cub, that we dynoed with the PVRs. So we've been playing with intakes on it. We had got a email saying that we dynoed a few of the intakes wrong, that we should have ran the stuffer in them, and we took the stuffer out for the Chariot ones, and we left it in for everything else, and that was wrong. So we went back there and redyed them on this different motor, but we got all the same intakes and stuff like that. So we'll see what it did. It was really interesting seeing what the stuffer does and does not do with intakes. And air-fuel ratios with different intakes and stuffers. So, intakes that we had the Chariot singles that we dynoed on there. Pretty standard. We had our intake. This is not the one we used, but it matches up. No, anything, just has the crossover. And then we had the same old Chariot that we dynoed on the other motor with the crossover and the little pieces in there on a little air shield dam things. So the issue was we took this piece out with our dyno stuff. The reason we took it out is if you look at how it matches up a lot better. It's hard to see with the light here. A lot better with nothing in there. You can see nothing there. If I slide the stuffer in, you see the whole stuffer. That's what it looks like. So I wouldn't think that would flow very well, but it was super interesting seeing how it worked. So first ones we started with on this motor was our intake, the same one we dynoed with this one on there. My hand's gonna be a little shaky here. But it made 119 and 6361. That was with a 185 main jet, 39 PWKs, standard setup, nothing. Air fuel looked pretty good on it. The next ones we did was the Chariot crossover ones with the stuffers in. So we put those in. They made 117 and 63. So they look pretty good. Same as ours all the way, really, and they lost just a little bit up on top, so really not that bad. So surprising enough, they worked really good. Next one we did is we took that same intake, the blue line, we took the stuffer out of it. So it picked up a ton of mid-range, but it killed the top end. So for an all-out dune kind of play motor, picking up some mid-range, it really did pick that up. I mean, we made almost 3/4 of a foot-pound more than with the stuffers in it. Less horsepower, but if you're not riding up there, it probably isn't going to matter. Now, the interesting thing here was the air-fuel ratio between the manifolds. So this is all with a 185 main jet. The red line ones is this yellowish-orangish one, so it's a little lean. I mean, I would probably richen it up a little bit to send the customer, but it's not horrible. Just changing the intake, it leaned it out, or excuse me, richened it up quite a bit. And then taking the stuffer out, it richened it up even more. So it definitely could come down a little bit. So the next test, we did drop down the main jets. So it's the same intake with no, no stuffer in the Chariots with the 178 main jet. So it made 115. It picked up like little, 3/4 of a horsepower, picked it up a little bit. But it lost a lot of the torque in the mid-range. You can see here this dark blue line, that is our air-fuel ratio, so it went from this red one to this blue one. So it definitely leaned it out a little bit. If we go back to torque, it lost almost not quite a foot-pound of torque. We picked up some horsepower, but lost that torque in the mid-range there, not having that fuel. So I would probably say I'd leave it rich for a Duner motor. I think it's going to be more fun to ride. Now, the next one we tried was the Chariot singles with still the 178 main jet, and these have no stuffer in them. So they had really good power in the mid-range. 64.5 foot-pounds of torque, comes on really strong, fell off on top a little bit, 115.41, but still a really nice curve, looked really good. Next one was the Chariot singles with the stuffer in them. So it's going to be hard with all these diagraphs seeing them all, but we're just kind of looking here. So that made 117.48 and 64 foot-pounds of torque. So really pretty good everywhere. Really like that one. It worked really good on there. Lost a little bit. You can see ours is the orange one. There's the brown one. But all the way up the face, theirs is stronger. So it worked really good. The next one is we took the red line intakes on there and no stuffer. So I had never ran them that way before, so it's kind of interesting to see. So we made 11780 and 63.5, almost 64 foot-pounds of torque. So I'm gonna try to, how can we see this better? Comes off pretty good. Really doesn't lose anything anywhere, but you can see same thing with no stuffer in ours. The screen's really dirty. The orange one's without the stuffer, or with the stuffer, and this kind of greenish one is with the stuffer out. So it definitely likes the top end power with the stuffer, and it definitely keeps the air going where it needs to go. Then just to start it all back off, to show that everything was the same on there, we went back and put our intakes with the stuffers back on there, and it made 118.91 and 63.80 for torque. I mean, had pretty much the same exact curve from, you know, I don't know what the time difference was on all these, but it was, you know, 3:30. We started at 11:40. So we had, you know, 3.5, 4 hours worth of time there that we changed, and nothing. I did put the 185 main jets back in with our intakes, which I thought was really interesting. So if we get rid of some of these intakes on there, let's just do the crossover to crossover ones here. So we have, let's make sure we got the right ones. The Chariots with the stuffer in it, they made 117 and 63. Everything looks really good on there, good torque on them. They're all in the ballpark, all good intakes. But you go to the air fuel, and this is why we lean down the Chariots a little bit to bring the air fuel up, ratio up a little bit. Theirs were really rich. We had a 185. We ended up going down to a 175 with theirs, 178 with theirs, excuse me, to bring this up a little bit to make it more kind of even, get the air fuel right. You could probably go a little bit more, but remember when we leaned it down, we lost a little bit of that mid-range. I was trying not to lose that. I was really surprised that we could run a 185 with ours, and it still had, you know, probably add a little bit more fuel to it, right at 13-1. So for a drag bike, I'd leave it. For a dooner bike that's going to be out there running a lot, I would probably richen it up a little bit more on the needle if they're cruising, or just, you know, doing a little bit of everything. Maybe go up on the main jet just a little bit. But kind of interesting seeing what the stuffer does. I'd never played with it to see how big a difference it did. It seems like it taking the stuffer out makes a lot of mid-range, and putting it back in makes a lot of top end. So you might play with it on your bike, depending on what intakes you have, and see if you can tell the difference. So pretty interesting.